Okay, limit at x is approaching infinity. Let me just try do a direct substitution. So really large number minus really large number squared, and 1 plus x over x. That's 1 over x plus x over x. So 1 over x plus 1. That's essentially approaching ln of 1, right, which is approaching 0. Okay, so this is definitely indeterminate, right? We have infinity. We're not sure who's winning the war here. You know, is this growing much faster than the 0? Or is the 0 growing faster than the infinity squared? Okay, so the form that's given right now, we can't determine that clearly. So we gotta change this form a bit. Okay. And usually this limit at infinity, it's a fractional expression, not like a subtraction like this. Okay, and the trick is to factor out still, you know, typically you factor out the highest power from the numerator and the denominator. Here still, let's factor out the highest power, which is x squared. And we get 1 over x ln of, let me write this as this, 1 over x plus 1. Okay, and because I want a fractional expression, I'm going to bring that down under. Okay, so x squared is equal to 1 over x squared. So at the bottom here, it's 1 over x squared. Okay, so now let's sort of substitute the infinity again. We get infinity, so this is 0. This is also approaching 0. At the bottom also 0. So we have a 0 over 0 case. It's an indeterminate form. So we could use the L'Hopital's rule here. But, and I actually tried this, and I want to stop you from why you should do that. If you differentiate it here, because of the 1 over x, and at the bottom it's 1 over x squared, the derivative gets complicated, and your algebra just explodes into this big confusion. Okay, so if you recognize that we have a 1 over x here, 1 over x here, and this is actually a 1 over x squared, you let 1 over x equal to u. In other words, x is equal to 1 over u. And convert this limit all in terms of u, it becomes a much nicer equation. So as x approaches to infinity, from here you can see that u will approach 0. Okay, let's change all in terms of u. You get u minus ln of u plus 1. And here it's going to be 1 over u squared, right? Because 1 over x is equal to u, this becomes u squared. Okay, now so the derivative of this is going to be much simpler. Now let's apply L'Hopital's rule. And we get 1 minus 1 over u plus 1. Here you get 2u. Okay, it's still, right, it's still 1 minus 1. At the bottom is 0. It's still 0 over 0 case. So let's use L'Hopital's rule one more time. Okay, so that turns into 0. That right there would turn into minus 1 over u plus 1 squared. At the bottom is 2. Okay, so in here, let's clean this up first. We get 1 over u plus 1 squared over u. Now if you plug in 0, you get 1 over 2. So that's the limit. Okay, so there's two tricky moves in this question, from here to here, and converting the x all in terms of u. Okay, if you miss one of the two steps, so this step is actually it's a must if you want this question to be simple. This one is absolutely necessary. Okay.